In our last module, we successfully recorded an animation sequence asset for our MetaHuman face performance. In this module, we'll begin the process of looking at how we can edit and use these assets in our Unreal Engine level. Before we get too far into that, let's do a little housekeeping first. I'm going to close the animation sequence editor and also close the take recorder, as we won't need that any further. Next, I'll return to the content browser. And here is our animation sequence asset as recorded by Take Recorder. I'd like to preserve the original recording and always work on a copy so that if I ever need to return to the original recording, that file is always available. So I'll open our source panel for the project and create an animations folder specific to our MetaHuman. So I'll expand the MetaHumans entry and then expand the entry for Danielle, which is this MetaHuman. Here, I'll right-click and create a new folder for animations. So right-click, new folder, and entering in the word animations. Now that we have a folder to store our Danielle animations, we can go back to the Take Recorder animation folder, and then click and drag this asset over to the new folder. When I release, I have this pop-up menu where it gives me the option to move, copy, or advance copy. A simple copy here is all we need. This will copy the asset file over, preserving the original, so that we can always go back to it if necessary. Finally, I can click on our new animations folder for Danielle, and we see that this copied asset has a star in its tile. This indicates that it hasn't been saved as a file yet, so let's take care of that by right-clicking and choosing Save from the pop-up menu. Once this is fully saved, we can go ahead and close our source panel here by clicking this button. And now we're ready to begin editing. In this module, we'll mainly look at the animation sequence editor. To open that, we just double-click our animation sequence asset and return to the animation sequence editor. Let's maximize this window, maybe expand the viewport, and use our standard viewport controls to move in close to our face so that we can take a good look at the performance on our MetaHuman face model. Now, one of the things that we'll notice about our animation sequence is that there are 1,000 curves recorded here. This is every possible value that could be recorded about the MetaHuman face. Most of these values are actually being procedurally driven by the primary control curves. So if I were to scroll down further, we'll note that some of these curves contain WM. This represents wrinkle maps. These wrinkle maps are actually driven by the primary controls, and any time our character scrunches her face, we activate the wrinkle maps to simulate the look of wrinkles as well as the shadows using the color map. Another set of procedural curves are the LOD curves. These represent level of detail, and again, they're procedurally driven by the primary curves. So we can dramatically improve the efficiency of this asset by deleting all the unnecessary curves. Let's start with the LOD curves. I'll go to my filter entry here and type in the letters LOD. Now, only curves that contain LOD are being displayed. If I select one and then use Control A, I've now selected all of the LOD curves, and I can right-click and choose Remove Selected to delete them. This brings us down to just over 300 curves. Now let's get rid of those wrinkle map curves as well. I'll go back to my filter, type in WM for wrinkle map, and again select a curve and use Control A to select them all. Finally, right-click, Remove Selected, and now we're down to a nice manageable 262 curves. Let's clear out our filter, and finally, Apply, and Save. So now we have an asset that has only the 262 primary curves in them. Now let's take a look at how we can edit those curves individually. I'll hit pause here on our playback and take a look at the eyes. Here, the eyes dart off to the left. Let's see if we can adjust the degree to which these eyes are moving to the left. First, we'll find the curves related to the eye direction. So in our filter, we'll enter in EYE for eye. Scrolling down here, we can find that there are some curves called look up, look down, look left, and look right. Here our character is looking to the right of the screen, but since she's facing us, that's actually a look to our character's left. So we're interested in editing this look left for the left eye and look left for the right eye. Let's select these two curves and right-click and choose Edit Selected Curves. This will open our curve editor, and rather than load all the data from those 200 plus original curves, we're only loading in the data for the two selected curves, making the editor much more efficient. So here we are in the timeline, and here is the peak of the data as our left and our right eyes look off to the left. Let's take a closer look at this by using our left mouse button, click and drag to select these keys, and then tap the F button to frame or fill our view with the selected keys. So there are a number of ways that we could edit this set of keys. I'll start by selecting just the keys that are involved in looking to the left. Before and after this moment, the eyes are roughly in the center. Now I can use the transform tool to freeform transform these keys. Clicking on this control here activates the transform tool. One of the things that we probably want to deactivate here is snapping. We wouldn't want to adjust any of the fractional values for our time positions, nor do we want to be limited in snapping our vertical values for these keyframes. So let's deactivate both vertical and horizontal snapping here. Now, as a safety measure, we wouldn't want to move the time location of any of these keys. So our move control currently is set to allow movement in both axes. Let's click this dropdown and choose Y only. Now, if I were to click and drag on the transform tool, I'll only be able to move these keyframes vertically in terms of their values, but their time position will be maintained. Any transformation with this tool is going to be relative to the pivot point. So I could drag a corner or a side, or I could drag the entire control area. So if I wanted to lower these values just a little bit, I could click and drag and slide downward. I could also click one edge and slide to the center, or I could click a different edge and slide away. All of these adjustments are being made relative to this pivot point. So if I were to move where this pivot point is, then I would move the direction that my scaling is taking place in. So for example, with the pivot in the center, if I click on this top edge and move upward, you'll notice that the bottom of the transform is moving downward, away from the pivot. If instead I wanted all of these keys to move relative to the lowest key value, I can click and drag the pivot point, bring it down to the bottom of my transform area, and then click and drag this top edge, and you'll see that the keyframes all scale relative to this pivot point. These changes I don't want to keep, so I'll go ahead to Edit and Undo Transform. This brings us back to our original curves. There is another way of maintaining our original data. Let's deselect all of our keys, and with just these two curves selected, I can right-click an empty space here and choose Store Curves. By doing that, these two curves in their current state have been stored in memory. So if I select a number of keys and move them around, and do it again, you see this ghost of the captured curves that I recorded by using my right click. Let's make sure we deselect all our keys. By using that Store Curves. Now I'm not going to click that again, but if I want to restore those original curves, I can choose Apply to Stored Curves. And now my original data is returned. One other adjustment that I might want to make here is to adjust all of these values relative to their present values. So rather than selecting and using the transform tool relative to just the values that have been selected, I might want to adjust these values relative to where they are currently. There's a really nice way of doing that. I'll select my arrow button, select just the keyframes involved in this look, and then here, for the Y value of multiple values, I'll enter in equals 0.5. What I'm doing here is entering in a value that I will multiply all the keyframes by. So I'm multiplying, and the value I'm multiplying by is equal to 0.5. And this will lower all of the values by half of their current value. Simply hit enter to apply, and now we can see that curve is adjusted. If I wanted to restore this, having known that I just multiplied by 0.5, I could just as easily multiply by 2 to get back. So again, with multiple values selected, I can type in star equals 2. This will now multiply the current values by 2, hit enter to apply, and we've got our original values back. Besides editing key values directly, it's also useful to be able to filter values to smooth the data that we already have. Let's use a different curve as an example of this. We'll close the curve editor. Let's focus on the movement of the eyelids. To do that, we'll find the curves that drive blink. So we'll replace eye in our filter with the word blink. Here we find two curves, blink left and blink right. We'll select both of these, right-click, and choose Edit Selected Curves. Here we see all the keyframe data related to the two blink curves. Let's take a look at this area. It looks a bit noisy. We'll drag select these keyframes and tap F to frame them up. And here it is, this area right here, where we seem to have a lot of up and down motion. If we hit play in this area, we can see a little bit of flutter in those eyelids. It's a little distracting. Let's filter that out. So again, I'll select just the keyframes that I'm interested in filtering out right here. Now let's open our filtering options. We do this with this last button here in the toolbar. Clicking this opens up our Curve Editor Filters panel. Let's move this out of the way and select Fourier Transform. FFT stands for Fast Fourier Transform. It's a great filter for smoothing out data. The real nice thing about this is it can isolate low-frequency data from high-frequency data. A low-pass filter type will allow the low frequencies of overall motion to come through, while filtering out the high frequencies that are causing high jitter and noise. I usually use the Butterworth response, so we'll choose that, and a cutoff frequency adjusts at what level the high frequencies begin to be filtered out. At 0.8, these are very high frequencies. I'm going to set this to 0.5 so that a larger bandwidth of frequencies on the high end will get filtered out. Again, our filter is going to be applied to our selected keyframes, so let's keep an eye on those as we hit the Apply button. Now we can see that the vast majority of this data has smoothed out significantly. We can use the Apply button again to continue filtering. We are starting to see a little bit of an artifact here on the very first keyframe. As these get smoothed, there's a little bit of error resulting in these keyframes being increased instead of smoothed out. So let's just delete these first two frames here and allow the values between to be interpolated. We'll just hit the delete key with those selected. And there we've smoothed out the data. I can close my filters panel and hit play. We see much less flutter in the eyelids. To finish all of our changes, we'll make sure we click Apply, and of course Save to record all of our changes. With that, we're ready to move on. We'll use our animation sequence in the sequencer in our next module.